Today we are going to talk about thin lenses. A lens is a transparent object that converges or diverges light by refraction. A converging lens is thicker at the middle. A diverging lens is thinner at the middle. Light actually bends at each surface. However, for thin lenses, we can show light bending only once at the center of the lens. Focal length is the distance from the focal point to the center of the lens. Rules for drawing reference rays. These are few rules which will help you to draw the diagrams for lenses. Based on these rules, try to complete the ray drawing to locate the image. Images created by converging lenses. There are few cases of images created by converging lenses. The first case is when the object is at infinity. When the object is at infinity, the image which we are going to provide is just a point at focus. Applications: burning a hole with a magnifying glass. The second case is when the object is in a distance more than 2 focal lengths. If the object is in a distance more than 2 focal lengths, then the image which we are going to provide is real, smaller, inverted, and it's going to be between f and 2f. Applications: lens of a camera, human eyeball lens, and objective lens of a refracting telescope. The third case is when the object is in a distance 2 focal lengths from the center of the lens. So if the object is on 2f, the image which we are going to provide is a real image at 2f, same size as the object but inverted. Applications: inverting lens of a field telescope. The fourth case is when the object is between 2f and f. So if the object is between focal length and 2 focal lengths, the image which we are going to provide will be magnified, real, and outside 2f. Applications: motion picture or slide projector and objective lens in a compound microscope. The fifth case is when the object is at focus. If the object is at focus, image is at infinity. So application: lenses used in lighthouses and searchlights. And the sixth case is when the object is inside the focal length. If the object is inside the focal length, we are going to get a magnified virtual image on the same side of the lens as the object. Applications: magnifying with a magnifying glass, eyepiece lens of microscope, binoculars, and telescope. Diverging lens diagram. We can complete the ray diagram for the lens by remembering 3 rules from the table 2. What were the 3 rules? I will remind you the rules. The rules were that we have to draw 3 incident light rays, one parallel to the x-axis, one through the focus, and the other one through the center of the lenses. Once you draw these 3 incident light rays, you are going to get this image as shown. Thin lens equations. Thin lens equations is 1 over distance from object to lens plus 1 over distance from image to lens is equal 1 over focal length, or 1 over p plus 1 over q is equal 1 over f. Also, magnification of a lens. Magnification of a lens is equal image height over object height is equal minus distance from image to lens, or distance from object over distance from object to lens. Sign conventions. P is positive if the object is in front of the lens. Q is positive if the image is behind the lens, real and inverted. Q is negative if the image is in front of the lens, virtual and upright. F is positive for converging lenses and negative for diverging lenses. H and H prime are positive if upright and negative if inverted. Nearsightedness. The image forms in front of the retina, possibly because the retina is too long. What type of lens is needed in front of the eye to correct the problem, converging or diverging? All what we need to do is to bring the image to retina. To bring the image to retina, we have to open a little bit the light rays. To open the light rays, to spread them up a little bit, we need to use a diverging lens. In this way, The diverging lens will spread up the light and the object is going to reach the retina. Farsightedness. The image forms behind the retina, possibly because the lens is inflexible. So, what type of lens is needed in front of the eye to correct the problem, converging or diverging? All what we need to do is to collect these light rays in a way to bring the image to retina. So to bring the image to the retina, we have to use a converging lens. By using a converging lens, the light rays will be collected and the image will reach the retina. So the problem is going to be fixed. Combination of lenses. Microscope and refracting telescopes use two lenses. The objective lens forms a real image that is located inside the focal point of the eyepiece. The eyepiece magnifies the first image, creating a large virtual image. That was all for thin lenses. Thank you for watching.